Alright, we are starting our first chapter 2 lesson today. We're talking about sets. The concept of sets is the basis of this video. So top one right here is what we're looking at. Now, as we talk about the concept of a set, let's set it up first with a definition. So, starting out here with the definition here. Let's get our font a little lower here. Alright, perfect. So, what is a set? Essentially, a set is a collection of elements which can also be considered members of the set. Okay? Simple stuff. Okay, so we can use many examples when we're talking about this. Let's start just by a basic example. Okay, for example, we have set A. And the way we do this, we say A equals and then use a brace generally. So set A is 1, 3, and I'm just making this up, okay? You know, sets can be defined to be anything you need it to be. Right now we're just using the odd numbers that are greater than 0 right now. So that's what set A is. Just a basic example. Please excuse my handwriting, but that's pretty much what we're talking about with a basic idea of a set. Now, to further classify this, we can talk about well-defined sets. So a well-defined set is just basically a type of set. So let's talk about that real quick. Now, once again, setting the font and getting it right, there it is. A well-defined set is essentially a set that has elements that can be clearly defined. I make this real simple, okay? Let's fix up clearly here real quick. Make this more simple, okay? Clearly defined, essentially what we're talking about is facts, okay? And let's make sure that we understand this with the next example. So, with the next example, I'm going to set you up with 4 different sets, and it's your job to determine which of these are well defined. So, which one of these are facts? Take a look, okay? I'll give you a second, you make the decision, okay? Back in a minute. Alright, we're back now. You should have the answer to this at this point in time. So, here we go. In looking at this, well-defined sets, well, let's see. The set of the students in this class is an absolute fact. There's no question about that. That is well-defined. The set of the 3 best movies, well, it's an opinion. You and I are going to differ on that, but we don't know who's right. That's why it's not well-defined. Knock it off the list. Set of the worst flavors of ice cream, once again, not well-defined. It's an opinion. Knock it out. That's not right. However, the set of U.S. presidents is an absolute fact. There is no opinion. So that's me illustrating to you the difference between well-defined and not well-defined sets. Should be pretty simple at this point in time. Now, there are 3 different ways to actually describe a set, or to actually write a set, to express it is a better way of looking at that. The first one we're going to talk about is going to be roster form. So, again, setting the font, here we go. Now, roster form, or descriptive form, excuse me, is describing but not listing all the members of the set. An example of this, we could say the set of all odd numbers greater than 0. Once again, we didn't list out what those numbers were, but at the same time, we did describe them. So that's an example of a descriptive set going on right there. Now, the next way we can express sets is in roster form. So, coming down to roster form right here, what specifically is roster form? Well, roster form is basically when you use braces and just basically list all the elements of the sets. So we're going to call that as listing all of the elements of a set in braces. And I will help you out and describe that for you. Okay, so if we're listing them all in braces, let's use our previous example. Our example here is that we want to have set A, and set A is, and we'll use the same thing, set of all odd numbers greater than 0. 1, 3, 5. Notice how I'm actually listing out what those are. That's the difference between descriptive and roster format. And I'm going to put a dot, dot, dot here at the end because it's not done. there at 11. It keeps on going forever, but that's that idea, okay? So roster as well as descriptive format should be pretty solid. The tougher one to do is set builder notation. Now, let me set you up on set builder notation as well. Starting out on set builder notation, the way we do set builder notation, again, fixing the font, get back there you are, is to do set builder notation, we essentially set it as the name of the set as well as a condition, and I'll write this out. So we start out with a letter. Our set is going to be set D, for example. We then set up an actual equal sign. The next set is a brace. Next you will have X. This is the actual element you're using. A line. This line indicates such that. And then there will be a condition, okay? After that, you will have an actual bound going on in this case. So let's do an example of this one to make it a little simpler, okay? Our example here is we have set E, okay? There's the name of our set. It consists of all x's such that x is an element of, we're going to make it an element of the natural numbers. That's how I signify naturals. We will talk about that in a second. And of these naturals, our x's are greater than or equal to 2. Again, I'm just listing out an example of set builder notation, but that's how we describe it. We'll do a couple of examples to make this clearer for you. All right, real quickly, we need to know what natural numbers, whole numbers, and integers are so that we can actually define them. What natural numbers are? Natural numbers are essentially going to be 1, 2, 3, 4, ... going on. That is the set of all natural numbers. What does that mean? Well, it means essentially it's bigger than 0, and it can't be negative in this case. All positive numbers, not 0, not negatives. When we get into whole numbers, we're once again going to have all of our natural numbers, but we will also have 0. So it's 0 and all positive numbers. 0, 1, 2, 3. Ooh, that's a fun 3 going on there. 4, and the ... going on. So again, natural numbers end up just being positives, whole numbers are 0 in positives, and integers, which we use an I for. Integers are all negatives, all positives, and 0, but they have to be whole numbers. All these have to be whole numbers. What's that mean? No decimals, as well as no fractions. All whole numbers going on. But integers can go in either directions, negative and positive. Now we had to define that to be able to take care of our next step. Next step, write a description of the set containing January, February, March, April, May, June, July, August, September, October, November, and December. Well, when I'm looking at that, I'm writing a descriptive. What are those example of? Well, I say that is the set of all months. Should make sense. Pretty easy stuff. Those are all months. Now we get more descriptive down here on the next one. The next one says, write a description of the set containing just June, July, and August. So, all right, now there's still months here, but they're specific months. What type of months are June, July, and August? Well, I think that is the set of all summer months. Notice how descriptive format works. We just write out what we see in a descriptive format. Next up, we're going to talk about roster form. How do we do roster form? Well, in order to do roster form, we're actually going to use braces and list the elements within the set. So we have the set of all whole numbers less than 6. All right, whole numbers. All right, let's see. What are whole numbers? Well, from my previous slide, I learned that whole numbers were 0 and all positive numbers. So if we're less than 6, we are 0, 1, 2, 3, 4, 5, and 6, right? 4, 5, and 6. We're good, right? Oh, hold on now. Less than, not less than or equal to, just less than. And therefore that 6 needs to be deleted because we cannot be 6 if we're less than 6. Pretty simple idea though. Let's go on to one more. The set of all integers between -1 and 4 inclusive. Inclusive means it includes those numbers. So if we're going to be from -1 to 4, including -1 and 4, I think that goes -1, 0, 1, 2, 3, and 4. And we do include 4 because of that word inclusive. Inclusive means it does include those elements of the set. All right, last one we're going to do, set builder notation. This is the tough one here. Whenever I set it up, I start with the name of the set, A, equals all elements X such that. Now you got to make X an element of something. It's either integers, whole numbers, or natural numbers. These look like natural numbers to me. Element of the natural numbers, and then you put a condition. We are all natural numbers that are less than or equal to 10. Simple. That works. It's a good example. There are multiple ways to describe this, though. I could have definitely come here and said, well, I want, instead of that, I would like X to be less than 10. Less than 10 also works in this case. Okay, so there's multiple ways to describe it, but it's got to be correct to work. Last one, set B. Set B is the set of all elements such that X is an element of, all right, X has got to be a negative or a 0, so it's got to be an integer, and X is, well, let's see, it is greater than or equal to 4, and less than or equal to 0. So, multiple ways to do this stuff, guys. Multiple ways to do it, but it's got to be right to set it up. This is an example of our first video. More to come. Hopefully it